What's Gucci, everybody? It's AJ back again, and today I want to make a second video in graph theory. If you haven't watched the last video where I left off, please watch that. I'll include a link in the video below, or in this video. But where we're going to start here today is we're going to start on something I didn't cover in the last video, degrees. Now, degrees, as you see in the above definition, is the number of edges touching the vertex. And you're going to see I mean that quite literally. So if I draw a graph here, 1, 2, 3, and I have them all connecting, or maybe I won't have them all connecting, I'll just have 1 to 3 and 3 to 2, you can see that 1 has a degree of 1, the 1 vertices, 3 has a degree of 2, and 2 has a degree of 1. Now, by quite literally, I meant that the number of edges touching the vertex. So that is literally the number of lines touching the vertex. And what you want to do is, so you can see the self loop I made here is 1 edge touching the vertex, but technically it's 2 edges touching the vertex. So that's something you want to look out for, is that self loops count as 2 degrees. So technically the one vertice has 3 degrees now. Self loops count as 2. Every other regular edge to a different vertice counts as 1. So that's all you need to know on degrees. Now we're going to learn about the definition of bipartite graphs. As you can see, a bipartite graph is a graph whose vertices can be divided into 2 sets such that all edges connect a vertex in one set with a vertex in another, and they cannot break the rule. So that means you can look at the graph as 2 sets, 2 kind of alternating sets in terms of how the edges connect, and that one vertex must connect with a vertex from another set. So as you can see here, what I'm going to do is, don't mind what color the edges are, I'm going to connect 0 with 1 because that's possible. I'm now going to connect these kind of, in a ring around the rosy kind of way. And as you can see, as I've shown with the black and the red, there are 2 sets. There's 1 and 2, and then there's 0 and 3. And basically, when 0 can either go to 1 or 2, but they're both in a different set, and 3 can either go to 1 or 2, and that's in different sets. Same with 1, it can go to 0 or 3, but they're in different sets. But in no way should this wouldn't be a bipartite graph if 1 was able to go to 2, because then I would either have to rearrange the sets. 1 and 2 would have to be in different sets, but that would not be possible because I would need to divide them into more sets to do that, and I must only be able to divide them into 2 sets. That's the rule. So bipartite graphs have 2 sets such that the edges sort of alternate in one set with a vertex in another, as you can see with the graph I showed you guys here. This is a basic example, but obviously they can get bigger. Just know that in a bipartite graph, the edges, you can put the edges into 2 sets, and that if you go from edge to edge, you should alternate the edges, the sets. You should alternate which set you're in every time you cross an edge. So as you can see, I go from 0, I'm in this edge, I'm in this set, and then when I go to 1, I'm here when I'm in 0, and then when I go to 1, I'm in this set, and when I go to 3, I'm in the other set, and when I go to 2, I'm in the other set. So in bipartite graphs, you should be able to there should be some way to put the vertices in 2 sets that you're always alternating when you travel around the graph. Okay, so for now, we've just been dealing with standard graphs. We've been dealing with graphs where we have 0, we have vertexes 0 and 1, and we can go back and forth. You can go this way, and you can go this way. Well, now we're going to deal with directed graphs, which essentially, the edges only have one way to go. You can't go back and forth as with undirected graphs, which we've been working with, which are usually the graphs you see unless it's specifically defined like we're about to do. So a directed graph is a set of vertices in a collection of directive edges. So what I'm basically going to do is my edges now are going to have pointers, or going to have directions that you can only go there. So I'm going to have 0, 1, and 2, and I'm going to have 2 edges, except the only path I can take, or the only way I can go on these edges, is to 1 for this example. I can only go this way, and I can only go this way. It is possible to have 2 edges like this in a directed graph, so I can go back and forth. That's the way you would symbolize it. You want to draw like a straight line with no pointers, or you can do or you can, but you can still have as many paths as you want. But it just notes that, like, for instance, you can have this. You can only go in that direction. So there are so graphs. This is obviously to be more specific. For instance, as sometimes there's no way to get back to maybe where you started. For instance, in this graph, there's no way to get back to 2. If you start at 2, you can go from 0 to 1, or you can just go to 0, as you can see here. So So now, also something I want to point out in graphs, directed graphs, is you can have paths and cycles just like we saw in the last video, which again I encourage you to watch, that we can use. So again, there's a directed path, which is, edges pointing from each vertex from the sequence to its successor. So for instance, a path in this graph would be 2 to 0 to 1, and that would simply be it. We also can have a cycle, which is a directed path with at least one edge whose vertices and whose the first vertices and last vertex are the same. So to have a cycle, or a directed cycle, I would have to go from 2 to 0 to 1 to 2, and that has a length of 3, as you can see. And so that would be a cycle, and that'd also be a simple cycle, because a cycle you can't go to the same vertex twice. In a simple cycle, you can only go to the same vertex twice at the end, but in a regular cycle, you can go to the same vertex as many times as you want, and you have to end up at the same vertex twice. So just so you know, in directed graphs, the definitions of path and cycle still exist. Well guys, that's all I've decided to do for today. In another video, hopefully we can cover minimum spanning trees and other types of other directions where we have weighted graphs and other things like that. Thank you guys for watching this video. I hope you enjoy it. If you have any comments, please say. I enjoy harsh comments and kind comments alike. Visit my website if you want to see something cool, and have a great dandy doodly day.